Hi, thanks for coming to my TED Talk about PowerShell. My name is Dahvid Schloss. I'm the offensive security lead on cyber and risk. What that basically means is I lead all of our red teaming, pen testing, anything that kind of emulates a criminal activity or things like that. I'm running that. Real quick, just because the obligatory, we're a small company, I'd like to throw us out real quick. And we do offensive security testing, defensive security testing and compliance. It's really fun. I like it. I like to shout out the company whenever I can. So let's actually just jump right into it and talk about today's goal. Today I want to talk to you guys about PowerShell, and I want you guys to leave with a healthy paranoia around it. The way we're going to do that is we're going to first talk about the allure of PowerShell, why IT admins love it, why attackers love it. We're going to talk a bit about bypassing organic controls like AMZ, whitelist, the signed script execution. And then we're going to wrap it all up with some malware deployment and how you can protect yourself. So why do IT admins love it? Well, it's everywhere. Windows, Linux, Mac. I have it on my Linux machine. You don't need to learn Bash. You can just use PowerShell on Linux to communicate with Windows. It's great. It's easy to use and learn. It's one of the first applications that I learned, even before Python. And it enables more functions around remote administration. So you can take your hour-long, really resource-intensive task and turn it into 5 minutes. It's great. So why do attackers love it? Well, it's everywhere. It's on Windows, Linux, Mac. I have it on my Kali machine. I don't need to use Impacket to communicate to Windows from Linux. It's awesome. It's easy to use and learn. There is a lot of resources out there for learning offensive PowerShell techniques, and they're written pretty well. And it enables more functions around remote administration. So it makes lateral movement techniques relatively easy to use. So you can see that the attackers really have the advantage here. I think what a lot of people forget is when you have access to a terminal, scripts can be run entirely from memory. You can just copy and paste. There's actually no reason to have a script on disk, which makes this really difficult for signature-based AVs to detect this activity. It's scriptable.net. We'll get more into that a little bit later, but it's the main reason why we started seeing a shift from PowerShell to C#. And the last reason why attackers really have the advantage here is organic security functions are constantly getting defeated. People love to just find ways to defeat Microsoft. And then they brag about it on the internet. And because they brag about it on the internet, then it becomes de facto knowledge for attackers. So let's get into the meat and potatoes of why we're here. The first part we're going to talk about is this organic control, or bypassing organic control. And the first organic control we're going to talk about is script-signed execution. For those who don't know, this is a control in PowerShell that will stop a unsigned or untrusted script from running. What most admins would realize or recognize is this, when we try to do execution, set execution policy here to bypass, we actually have no permissions to do that. But this is relatively easy to get around. And it's the reason why this is not a security control. So really, when you want to go and set an execution policy to, say, bypass, which will make it so you don't need to have any sort of signed script, you can actually just execute PowerShell with TAC EP or TAC execution policy bypass. And it only sets it for that instance. This is the reason why this is not a security control. Microsoft has said it's not a security control, but only in their forms. The way they write this out in their documentation, they make it seem like it is. But it is relatively easy to bypass. The reason why this works in this way is when you run the command set execution policy, you're actually trying to change a registry key in the HKey local machine registry hive, which requires admin privileges. But the TAC EP or TAC execution policy flag is allowed to be run on execution of PowerShell. And it'll only set it for that instance. So you're not changing it for the entire machine. I wanted to throw this out first because I have had clients in the past who told me that there's no way I could run a script on their workstations because they had this set execution policy set to restricted. So now that you know that, don't treat it as such. So let's get into the real meat and potatoes of bypassing. We're going to talk about bypassing AMZ. For those who don't know what AMZ is the anti-malware scan interface that Microsoft has pushed out. It's an interface that allows security products to hook into different applications like the Windows script host or VB scripts, Office macros, PowerShell, you name it. In the context of PowerShell, it blocks known malicious scripts and functions. So the most common one that defenders and attackers would see is this IEX, or extended command, download string. This is quite used a lot, and AMZ will go out and actually just block it. It sees it as only being a malicious script, so you can't run that while AMZ is running. Additional to that, it'll look for known bad strings like Mimikatz, Bloodhound, PowerView, you name it. It'll go out and stop the execution of those scripts. Some antivirus applications that run this right now are like McAfee, Sophos, Kaspersky, Windows Defender, duh. And there's probably more. I just really didn't dig too deep into it, as Microsoft doesn't have something that's readily available from what I saw that lists out all the security products that use it. So now that we know about AMZ, how do we go about defeating it? Well, it's pretty simple. PowerShell 2.0 is usually installed by default, and it doesn't have AMZ. So because it doesn't have AMZ, it doesn't have automatic script block logging on suspicious scripts, which then thus it defeats two different security functions right there, right? So to caveat all that, PowerShell 2.0 does require .NET version 2.0. So that is not installed by default. But if you're running old applications that require .NET 3.5, then 2.0 is going to be there, and you are vulnerable to this downgrade attack. It's the reason why when you look at like PowerView.ps1, it tries to execute PowerShell 2.0. So to run this attack, really, really easy. In the screenshot, we can see the first thing I'm printing out here is the PS version table. The reason I'm doing that is so you can see it is running 5.1, which is the newer version of PowerShell. And I'm trying to echo AMZ utils. The reason why I'm echoing AMZ utils here is AMZ sees that string as being malicious, as you wouldn't normally call it. So it just blocks you from being able to call it. It's a test function. But by executing PowerShell .exe with TAC version 2, which is it's that simple, you can now echo AMZ utils. So these really easy way to get around, right? But what happens if you don't have 2.0, .NET 2.0? How else can you set AMZ into a failed state? Well, quite simply, when you do try to defeat AMZ, all you're trying to do is set the AMZ init failed to true. The reason why we're trying to do this is AMZ doesn't have a recovery function. So if you crash it or set that AMZ init failed value to true, it won't restart and it won't read anymore, which is great for that instance. So the most common method that has been used to defeat AMZ was the genius Matt Graber came up with this reflective method to call the AMZ utils function and then get the field AMZ init failed and send it to true. This was done back in 2016. And since it's been quite a long time, you know it's not going to work anymore. But up until about last year, this bottom command, which is just concatenation of AMZ utils and AMZ init failed, did work. And as you can see, though, now it doesn't. So we did a little bit of digging to see what was going on, and I'm going to show you exactly like how simple it was to get around this. The first thing that we needed to do is figure out, does concatenation no longer work? Well, simply put, no, concatenation still works. You can still defeat AMZ that way. In the first screenshot, I'm just showing you that AMZ is running. It is still alerting on AMZ utils as being malicious. And when we do our simple concatenation of AMZ utils, it does print. So where is it starting to get caught? So we need to go one step further. Let's see if we can get the field. So this bottom screenshot, we're doing concatenation on the function, and then we are finding the field for AMZ and it failed. And we're actually able to print all the information. So concatenation still works, and, in 2021, which is great. What really ended up happening, and shout out to the Secure This Shit page. You can find their link at the GitHub link below. Has a great write-up on this. But it turns out that AMZ is doing a little bit of some regex. So when you go get type and get field and then try to set value, the regex code then goes, all right, let's concatenate the information and see if you are typing in AMZ utils. So it captures all that, which is good. But rule number one when defeating anything in PowerShell is when in doubt, encode it out. At least that's my rule. So just avoid base 64, but because that's organic to PowerShell. But you can use hex. So taking the concatenated string like AMZ utils and formatting it to hex, we can see that our little hex code does print out AMZ utils without being blocked. So now that we have our hex into text, we got to turn our text back into hex, which gives you a nice little Dr. Seuss rhyme. But a relatively simple one-line code, which is just splitting up each hex and then converting each value back into a character, we can print out AMZ utils. Very, very simple kind of bypass. So using this Matt Graber method, we can execute just using hex. So what I'm showing here is I'm typing in AMZ utils, show you AMZ is functioning. We copy in the now hex encode, hit enter, and type AMZ utils again, showing that we have bypassed it. So a bypass method developed in 2016 with very minimal change is still viable today, which is pretty concerning, right? There's other ways about defeating AMZ, though. There we go. There's a lot of text on the screen, and you don't need to copy it or anything because it is just Rasta Mouth's direct method, which is patching the DLL. I think this is really cool, and I wanted to point it out because you're able to patch loaded DLLs in PowerShell using like C# code. This is just C# being ran in PowerShell, and it's loading up the AMZ DLL, finding the first couple bytes of AMZ scan buffer, and then patching out those first couple bytes so that it fails. What I think is really cool here and why I wanted to point it out is that it's proven a point that you can do a lot more than just editing AMZ from this regard. If you were really sneaky, you could probably reload hooked DLLs to get around some common hooked methods from EDRs. But what that looks like is very similar. The first thing I'm going to do here is type AMZ, just show you again that it is running. And now, copy in Rasta Mouth, no editing took place in this. Just copy and paste, hit enter, and when we rerun AMZ utils, it's going to come back and show that it is defeated. But this isn't getting caught by AMZ at all, and this has been out in public for quite a long time. The only thing I would caveat on this is it is using a function called add type. This creates a temporary DLL on disk and can be read by a antivirus system. So it is one way of getting caught, but you can use Matt Graber's reflective DLL loading to get around that. So what happens when you can't run code to bypass AMZ, right? Like there's restricted mode or constrained language mode, something in that sense. Well, the really cool thing about PowerShell is it's just a bunch of DLLs loaded on top of the command prompt, and somebody was like, oh yeah, this is like a PowerShell, bro. So you can just use living off the land binaries to create your own PowerShell. We won't get too deep into the code here as now we start to venture away from it, but it is something to be aware of as it does concern our application. The most common one that I've seen and the one I've used for years is this MS build shell, which is a C# project file that you can just build using the msbuild.exe. So what I'm showing here is you have a command prompt. I'm going to type in ps version table. That's to show you that there is no PowerShell loaded in here. And I call the msbuild.exe binary, which is included by default with the .NET Framework version 4.0. And all we're doing is building our CS project file, which is named MS build shell. And as you'll see, it'll come back with an error. That error is just the Matt Graber AMZ DLL. There's no editing there, but you can edit it. And now we have PowerShell, right? PowerShell 5.1. I exited out, show you that we are returning back to a command prompt. The only difference between this and a normal PowerShell prompt is that you don't have tab completion. But if you don't have access to be able to execute PowerShell because constrained language mode is there, you can just load the DLLs and it'll work the same way. Some other ways of doing this is like the PowerShell DLL project, which you can use multiple different living off the land binaries to call PowerShell. And personally, my favorite, which is the sync app publishing server, you can use netcat to actually capture a callback from that, and that would be a PowerShell prompt. Shout out to Red Team for some of the great red apps. I would definitely check them out if you guys want to learn more about app blocker, restricted language bypassing. So why did we talk about all that? Why did we talk about AMZ for like 10 minutes here? Well, it's all getting down to malware deployment, the bread and butter of any attacker. For malware deployment within PowerShell, all you need to do is really take your C# code and turn it into PowerShell and vice versa. That's exactly what we saw when people started moving away from PowerShell into C#. They didn't really have to reprogram anything. So to execute malware, we really only need a few things. We need virtual alloc and create thread from kernel 32. And we need the Marshall service to be able to copy the shell code into the allocated memory. And then the next thing we need to be able to consider here is avoiding AVs, despite not needing to defeat AMZ again. When you do create a new thread, the antivirus does have the capability to read that. So you need to still do some shellcode obfuscation, reflective method of calling DLLs, things like that. So this becomes quite easy to do. As you can see, this first line here is importing the virtual alloc from kernel 32, and that's just going into C#. The one right below it, that is using the Matt Graber reflective method to load virtual alloc. Very similar. You're still setting it as an integer pointer, and then you're calling a few unsigned integers. It looks almost the same. And the same goes for when you want to actually execute virtual alloc. The first one is C# code, and then the next one is our PowerShell. So translation becomes relatively simple, especially if you already have something available in one of the languages. So then the next piece would be, how do we obfuscate our shellcode? Well, this becomes even easier, in my opinion, than C#, as PowerShell reads bytecode as decimal instead of hex. So 0x00 is still 000, and 0xFF is 255. So you can do something like a Caesar cipher, which is pushing the bytes to the right or the left, depending on which way you want to go. So if we do like +5 on a Caesar cipher, 000 becomes 005. And 255 becomes 260, which is an illegal operation as it's an integer overflow. So how can we fix that? Pretty simply, we use modulus. And PowerShell has this nice little modulus operator, which is the %sign. So now we can do 256 minus or plus our offset, modulus of 256. And if our offset is 5, 000 still becomes 5. And 255 becomes 004. So we've solved that. What that all looks like is this. We're going to run some interpreter code from our PowerShell script. So our interpreter callback is an HTTPS reverse callback. Some things to note before we execute code. The first thing is the PowerShell PID, which is 11496. I'm going to show you that AMZ is enabled here, just to show I'm not cheating. And then another piece that I wanted to show off here is a different way of importing code. I've talked a lot about just copy and paste into a terminal, but you don't always need to do that. Even with AMZ enabled, you can still use the .NET web request function to create a new web request and then download that information into a variable. So that's what we're going to do here. We're going to download bsides.ps1 from our server. It's going to load into a variable, and then we're going to use the extended command to execute that variable into memory. Now we can invoke bsides, give it our offset value of 66, and hit enter. One thing to note is there is no alert like AV alert, right? So when we go back to Kali, we can see that we do have a session that is running. We do our get UID, we can see our low privilege user, and our PID is 11496, which is that PowerShell interface. So we are now running Meterpreter within there without being caught. So now that you may be a little paranoid and you've seen all this stuff, what are some of these things that we can do? How can we fix this? Well, quite simply, one of the easiest ways to do it is just disable PowerShell. I don't know of anybody who would ever give their users Python, so I don't know why you would want to give them PowerShell. Definitely look at expanding your application blacklisting. Not everything Microsoft provides to you is safe. I'm pretty sure most people remember DD Auto. That was fun. Use AI-based security products. Things that hook into kernel 32 or NTDLL to help determine maliciousness is always great, as well as being able to detect if a sensor has been disconnected. Those are quite important. And then the last piece is a little outside of all of our control, but Microsoft definitely needs to start fixing some of these holes. In 2021, concatenation still works, and I think it's partly because we stopped paying attention to PowerShell when everybody moved to C#. So these security controls didn't get as much love as one would expect. So it's definitely time for Microsoft to go back and look at this and start fixing some of these very simple bypasses. So past that, here's my information again. If you guys want to download these slides, you can go to our webpage at /BSides and get these slides yourself. If there are any questions, I am willing to answer them now. Thank you.